Hello, good evening. Good to have some of you here with me again today. And I guess this must have been quite an intense week for some of you because science practical has started. And I heard from some of my students that there was this last part of not chemical last part of chem practical. I heard that the last part of it was pretty time consuming. I'm not sure, but I'm hoping that you guys did fairly okay for your chem practical. And I'm also definitely hoping that you guys are not neglecting statistics, which we are going to be doing today. It is going to be a very, very crucial part of how we are going to be scoring for our H2 math. And that is going to be happening in less than 3 weeks' time. Just thinking about it makes me feel a little bit anxious, especially for a year that is like this, a year with this pandemic happening. I'm really not sure how it is going to be affecting the entire cohort in general, and maybe even the mindset of the examiner, or how they are going to be viewing your results. I'm so curious, to be honest. And but anyway, we are going to be looking at ACJC 2020 paper 2, and specifically section B. I heard from my students that paper 1 was a pretty tough paper for this ACJC 2020. I feel that for paper 2 section B, when I was doing this statistics, I don't find it a particularly easy statistics to do either. Neither is it very, very tough. But I do think that there's a certain level of challenge in this section B of ACJC. So let's give it a try, and we are going to maybe aim to finish it within 1.5 hours. So hopefully by 9:30 we can sort of like wrap this up. So let's give this a try together. The first question here is the Venn diagram kind of question, and I do think that you guys probably find this 5 part 2 very, very familiar now. I'm also pretty interested in how 5 part 2 can be done repeatedly, because I was just in a way, I was just lamenting to a student. I don't know whether you are here. Hello, Alvin. I don't know whether you are here watching the live stream now, but I was just lamenting that for a question that is like this, which actually appear in the A-levels for 3 times. I think in the year 2010, then after that 2015, and then 2018. Question number 5, part 2. And every time when it happens, it is not like impossible to get the question done. It is just the repeatability that I find a bit lacking in the way that I'm doing question number 5 part 2, because I'm always doing it from the more analytical point of view. I will adjust the areas of the Venn diagram and try to see how I can get the maximum possible and minimum possible areas which represent the probability. And I think some of you probably saw me doing that in EJC 2019 paper that we did a few weeks back. So okay, anyway, let's give this a try, because I'm going to make use of another strategy to do 5 part 2, which I saw what that was done in ACJC's solution. I'm curious about the repeatability, so I'm going to give it a bit more thought. But anyway, let's try part 1 first. It is a pretty okay and simple question, I feel. So for 5 part 1, PA union B is equal to 0.8. Probability of A given B is equal to 0.5. We know that A and B, they are independent, which means that if probability of A given B is equal to 0.5, since A and B are independent, that means probability of A, this is also going to be equal to 0.5. And we know that probability of A union B, this is equal to 0.8. And if I were to make use of the formula for A union B from my secondary school, this is going to be probability of A plus probability of B, which is what we are trying to solve for, and probability of A we have, that is 0.5, minus probability of A intersect B, this is equal to 0.8. Probability of A is 0.5, so it is fine. Probability of B is going to be an unknown. As for probability of A intersect B, I guess we can also rewrite it as probability of A multiplied by probability of B, since the question tells us that A and B, they are independent of each other. So probability of A plus probability of B minus away this is equal to 0.8. Now substituting probability of A, which is 0.5 in numerically, this is 0.5 plus probability of B minus away 0.5 multiplied by the probability of B, this is equal to 0.8. And now we will be able to solve for the probability of B, and this is equal to 0.6. It is definitely a useful number that I'm going to make use of, so let me write down 0.6 here. And let me move on now to part 2, which was what I was trying to tell you. I have been always trying to draw the Venn diagram, then after that subsequently adjust the whatever that I can be adjusting in my Venn diagram so that I can get the maximum possible area or the minimum possible area that represent the probability that we are supposed to find. And like what I was telling you just now, I don't think it is repeatable enough. So I have been trying to think of and work out a more repeatable strategy so that if a similar question were to appear in exam, it is easier for us to overcome it. So let me just make use of this that I've drawn. So we have A intersect B intersects C that I'm supposed to find the minimum of. So which means that we are looking at this area here. A intersect B intersect C. And for the information that we have so far, we know that A and C, they are independent of each other. So if A and C are independent of each other, we know probability of A intersect C, which is going to be this area here, can be calculated as probability of A multiplied by the probability of B, and probability of C. So this is going to be equal to probability of A. Just now we have discussed it is this, so let me write down here also. So probability of A, this is equal to 0.5. So it will be 0.5 multiplied by the probability of C that is given. It is multiplied by another 0.5, so this is 0.25. We are given that B and C are independent of each other also. So probability of B intersect C can be calculated. It is going to be calculated as the probability of B multiplied by the probability of C. Probability of B from the first part, this is equal to 0.6 multiplied by 0.5. So half of 0.6, this is equal to 0.3. In fact, we could have also written down probability of A intersect B. And this is going to be probability of A multiplied by the probability of B. Probability of A is 0.5. Probability of B was what we have found just now. So again, half of this is 0.3. So we know this area, we know this area, and we know this area. So let me try to do something that I saw ACJC did, and I modified a little bit. So, and I'm going to try to think a bit further after our session to see whether this process can be repeated. I'm going to try on the 3 questions in the TORS, and if they are repeatable enough, maybe during our workshop on the 5th of November. I mean, if I can find a way to repeat the process, then maybe on the 5th of November, I can share with you guys. So, and the next thing that I'm going to do, which I modify from what I saw in ACJC's solution, is to try to quote all the possible areas here in terms of probability of A intersect B intersect C. So I am going to try let probability of A intersect B intersect C. I'm going to try to let this be equal to X, which means that this area here is X. And if this entire region here is 0.3, that means this region here is going to be equal to 0.3 minus X. And if here, this entire region here, A intersect C, intersect z is 0.25, so this is going to be 0.25 minus x. Similarly, this is the region that is where B and C overlap. So this area here is going to be 0.3 minus x. We can definitely find this area also, this region. This region is a region that is inside A and outside B and outside C at the same time. So I'm going to take probability of A, which is 0.5. So I'll take probability of A minus away this, minus away this, minus away this. So I will be minusing away x, minusing away 0.25 minus x. And I'll minus away 0.3 minus x. And this is going to give me probability of A intersect B. This is going to give me inside A. This is going to give me x minus 0.05. So let me code it down here also. So this region is x minus 0.05. I'm going to continue to do the same thing for this region and this region. For this region, it is probability of A prime intersect B intersect C prime. So I will take the probability of A prime intersect B intersect C prime. It is this region that I'm talking about. So I'll take probability of B, which we have found it to be 0.6, minus away x, minus away this, and minus away this and this. So minus away 0.3 minus x, and then minus away another 0.3 minus x. And this gives me this gives me an x. So here is x. And finally, this region here, not finally, I realize there's still one more region, which is the outside. So this region here, it is probability of A prime and B prime and C. So I'll take probability of C, which is given to us as 0.5. Then I'll minus away x, minus away this, minus this, minus this. So minus away 0.25 minus x, minus away 0.3 minus x. And this gives me, this gives me x minus 0.05, which is the same as this region. So I have x minus 0.05. And finally, this entire region that is outside. So this region that is outside is the region that is outside of A and outside of B and outside of C at the same time. So this is going to be 1 minus away. Let's just minus away A union B, right? Since we are given it to be 0.8. Then I'll minus away this region, which is x minus 0.05. So now this is going to be equal to, let me see, this is going to be equal to 0.25 minus x. So I know this region here is 0.25 minus x. And why am I doing this? Because I know that for probabilities, because x is now appearing everywhere, and no matter where it appears, probability must always be bigger than 0, bigger or equal to 0, correct? So what I'm going to do is I'm going to make every single one of them bigger or equal to 0. For example, x by itself will be bigger or equal to 0. Then I'm going to look at this 0.25 minus x. So I'm going to let this 0.25 minus x. I'll let this be bigger or equal to 0. This tells me that x is going to be smaller or equal to 0.25. What else do we have? We have 0.3 minus x. So if I were to let 0.3 minus x be bigger or equal to 0, this tells me that x is going to be less than or equal to 0.3. And finally, we have this. We have x minus 0.05. And if I were to let this be bigger or equal to 0, this tells me that x is going to be bigger or equal to 0.05. And all these four must happen at the same time. Okay, because all the probabilities must be bigger or equal to 0 at the same time, no matter how I'm adjusting the areas. So if I were to now build for myself a number line, and on these number lines, I will have 0. I will have 0.05, 0.05, and I will have a 0.25, and finally I will have a 0.3. And according to what we are looking at here, x is supposed to be bigger or equal to 0. X is supposed to be less than or equal to 0.25. It is supposed to be less than or equal to 0.3. And it is supposed to be bigger or equal to 0.25, 0.05. And it must satisfy all these inequalities at the same time. So I'm looking at a common overlapping region, which happen to be this region here, which means that x is going to be bigger or equal to 0.05, less than or equal to 0.25. No matter how you do your adjustment, it is always going to be between these two values. And this helps me to find now the minimum. The minimum of x, which is the probability of A intersect B intersect C. This is going to be equal to 0.05, and we can find also the maximum possible of probability of A intersect B intersect C, and this is equal to 0.25. It is something that I am not very sure whether this process is going to be repeatable, but I'm going to just try to see how many times I can apply a process that is like this, such that at least it goes according to a rule instead of trying to do on the spot adjustment during the exam, which is extremely scary. But I have to agree that sometimes doing the adjustment in terms of the areas may actually be easier. So it really depends, okay? But doing this 5 part 2, I've decided I'm going to just try out this strategy, and I'm going to see whether it is going to be working for the 3 other questions. I tried on one of them, it seems to work, but it still took a little bit more time than how I will usually solve that by adjusting the area. So let me think about it for a little bit more. Next, let us take a look at another question. Question number 6. Question number 6. This is a discrete random variable question. Oh, I see a question. For PH, the reason why probability of A given B is equal to PA is because the question says that A and B are independent of each other. Okay. No, I'm trying to avoid this. Anyway, it's because the question says that A and B are independent of each other. That is why we know probability of A given B is equal to 0.5, and this can be very easily proven because probability of A given B is supposed to be probability of A and B divided by the probability of B. Which means that if A and B are independent, this tells me that probability of A multiplied by probability of B will be representing probability of A given B. Probability of A and B, then divided by the probability of B, this can be cancelled. That is why probability of A is equal to 0.5. And I'm using the 4 inequalities because I am trying to make sure that for all the probabilities that I can see here that are related to X, all of them must be bigger or equal to 0 because probability must be bigger or equal to 0. So I'm trying to relate everything as much as possible to X. So if I can at any one time make sure that all of them are bigger or equal to 0 and some of them are repeated. But that's why I'm left with just these 4 to analyze. Okay, like this and this, they are repeated. This and this, they are repeated. This and this, they are repeated. So there are only 4 different versions that I'm seeing here. So if I can just make all of them to be positive or equal to 0 at the same time, then that can possibly help me to come out with all the possible range of values for X. And if I can come out with the possible range of values for X, then that will give me the minimum and the maximum of A intersect B intersect C. Okay. Like what I was saying, it is a little bit lengthy In fact, if you were to look at the original ACJC's solution, they only did it for, I think, part of probability of C. That means not the entire thing like what I did here. So I was also wondering why they didn't consider the regions that are outside. Why do they consider specifically those few regions? I don't have a good answer for it, but when I tried myself, it does make sense. But like what I was saying, my issue is more of like the repeatability, which I'm curious whether a strategy that is like this, although it is tedious, but can I reapply it again? Because if I can reapply again, it will increase my chances of getting this correct in the exam. In case the area, shifting the Venn diagram to get a maximum or minimum area strategy fail in statistics, for this year. But seriously, I don't think this is going to appear again this year. Okay, I'm not sure. Okay, what if this comes out again this year? There's a chance, since the last time when it came out was in the year 2018, and I think that is why this year I see a lot of this appearing in prelims. Okay, anyway, let's take a look at question number 6. So for question number 6, we have 3 pairs of red socks. So we have 6 red socks, we have 4 white socks, and we have 2 black socks. And Drew, I just realized Drew is like drawing the socks out from the drawer. Okay, I'm not sure, but Drew randomly pulls out socks from the drawer, and one at a time. S is going to represent the total number of socks that Drew pulls out from the drawer, such that matching colors is going to be, until he managed to get matching colors. So S is the number of socks that Drew will be pulling out from the drawer until he's going to get a pair of matching colored socks. Part 1, I want to find the probability distribution of S. So I guess what we need to do is to try to list down all the cases and then try to calculate the probability of all the cases. Yeah, hello. I also hope that this question will not come out for the A levels. But when it came out in the year 2010, I was surprised because it was just a 1-mark question. But it is the same as this, so I don't know how it was done as a 1-mark question. And in fact, I was trying to look at how other schools solve that 1-mark question. Their solution is also like pretty long. Definitely not one that can be used to justify a 1-mark solution. Okay, anyway, for part 1 here, I'm going to try to list down all the possible cases and try to calculate the corresponding probability for every single one of the cases, and that should give me the probability distribution of S. So can S be equal to 1? Definitely not, because we are talking about socks that are of matching colors, so minimum it should be equal to 2, right? So for probability that S is equal to 2, it can be the first sock that is, let's say, red color. So if it is red color, it will be 6 out of, how many pairs of socks do I have? 6 out of 12. Then the next one is going to be red color again. So to be red color again, it will be 5 out of 11. Or we can be drawing white colored socks, and there are 4 pairs of there are 2 pairs of white colored socks, so there are 4 white colored socks. The first probability is going to be 4 out of 12. Then after that, 3 out of 11. And 1 black colored sock. So it will be 1 pair of black colored socks. So it will be 2 over 12. Then after that, 1 over 11. This is going to give us the probability of S is equal to 2. This is equal to 1 over 3. And let's move on to 3 pairs of socks that are being drawn. And let's say not 3 pairs of socks, 3 socks that are being drawn. So let's say the first sock is a red colored sock. And I'm going to make sure that the next sock is not red color. So there are 6 of them, 6 over 11, 6 non-red colored sock. And the last sock must be red color, so it will be 5 out of 10. Okay? And I'm specifying the first one to be hang on, let me think about something. I'm specifying the first one to be a red colored sock. So red color sock, red color sock, red color sock. Okay. Okay. Then after that, it will be a white colored sock. So it will be, if it is a white colored sock, it will be 4 out of 12. Then after that, it will be a non-white color, so it will be 8 out of 11. And then it is going to be a white colored sock again, it will be 3 out of 10. Or black colored sock, it will be 2 out of 12. Then multiply by a 10 out of 11. Then multiply by the last one, which is going to be a black colored sock again, so it is 1 out of 10. And this should give us a 74 over 165. Hang on, it seems like, let me think about something. Okay, hang on. I shouldn't be doing this. I should add some more things here. Oh, okay. Okay, I think I need to modify my solution. Because I realized I need to consider one more thing, which is for the first two socks here. I mean, the last one must be a red color. But for the first two socks here, it can be red, then non-red. Or it can be non-red, then red. So I need to multiply this by 2 factorial. Because I'm swapping these two positions for the socks. But the last one must be red. The same for this. I'm considering the white colored sock. The last one must be white color. Which means that the first one, it can be white, non-white, or non-white, white. So I must multiply this by a 2 factorial. So let me modify my answer a little bit more. So I should multiply this by 2 factorial. Then similarly for this, white, non-white, white, or it can be non-white, white. So these two can swap. So it will be another 2 factorial. This will give me 74 over 165. And then I can move on to probability that S is equal to 4. To move on to probability of S is equal to 4, for the first 3 socks, they must be of different colors. So let's say the first one is red, so it will be this. The second one is, let's say, white, it will be 4 out of 11. And the third one is, let's say, black, it is going to be 2 out of 10. And the last one, let me go for red, so it will be 5 out of 9. And I'm not going to miss out this time, so I'm going to multiply this by 3 factorial. The 3 factorial is for the first 3 socks, because it can be red, white, black, or it can be any other version, red, black, white, and so on. Okay. I'm assuming that you are asking about probability that S is equal to 3, right? So for this, it should be a 2 factorial because I am defining the last one as red. I don't want this to change. I'm defining the last one as white. I'm defining this last one here as black. So I'm basically permutating just the first 2. Okay, similarly for this, I'm permutating just the first 3. And I'm specifying the last one here to be red color. If I were to permutate 3 factorial, that means this last one, which I now specify as red, can also be in front, which means that 2 reds can happen, and that will be like the first case, which means that if 2 reds happen in the first 2 draws, Drew would have stopped, drawing the socks from the drawer. That's why we cannot do a 3 factorial. Okay, let me try to explain again for this. So the reason why I did a 3 factorial instead of a 4 factorial is because I want to make sure that the last sock, for the next case, right, I want to make sure that the last sock is a white colored sock. So I'm specifying the last sock to be white. And that is going to be, okay, I have to write down the first tree first. So this last sock must be white, okay? This cannot change. This must be a white color. So for the first tree, we can definitely still start with a red. Then we can go for a white sock, 4/11. Then after that, we can go for a black colored sock, which is going to be 2/10. So all the first three are different, which makes it possible for Drew to draw one more time, so that S is equal to 4. If there were to be already a repeat in the first tree, it will be either 2 or 3 for S. So now for 4, the first tree must be different, and the last one must be one of the first three. I'm specifying it to be white, and if it is white, this is going to be 3 out of 9. And for the first three, I can permutate them, so it is going to be 3 factorial. And if I were to go for one more case, which is for the last one to be black, so it is going to be 2 out of 9. The first one, let me go for a red. The second one, let me go for a white sock. So this. Then after that is going to be a black colored sock. Then it will be 2 out of 10. We'll be permutating these three, so multiply by a 3 factorial. This is going to get us a 12/55. Let's try to push our idea a little bit more by asking ourselves about probability of S is equal to 5. What I need to try to do is to think, is it even possible for S to be equal to 5? Because according to what we have discussed here, probably we should let the last one be red color, right? So it will be one sock, then another sock, then another one, and the last one, we're going to let it be red color. And in order for the last one to be red color, and Drew must draw 5 sock, that means all this must be of different colors, but there are only 3 colors. It is impossible for there to be 4 different colored socks when there are just 3 different colors. It is possible here because there are 3 different colors in front, which makes the last one, as long as it's the same as one of the first 3, then Drew would have drawn the 4th time, which means that this is impossible to happen. So all we have is S is going to be equal to 2, 3, or 4. In fact, if we have had considered probability of S is equal to 5 and above is impossible, if we have had considered this, we could have also tried to calculate probability of S is equal to 4 in a more efficient manner by going for 1 minus 1/3, this one, and minus away 74/165, this, and you will immediately give us this 12/55. Okay, provided that you can see that after you have calculated probability of S is equal to 2, then subsequently S is equal to 3, and then there's no more cases other than probability of S is equal to 4, then you can do a complement. And why can we do this? Because we are building for ourselves a probability distribution of S. And the definition of probability distribution is not just quoting down probabilities for a few cases. We are supposed to be quoting down the probabilities for all the cases. And that is why the sum of the probabilities has to be equal to 1 when we are talking about a probability distribution. Okay, I don't get the question here. 12 minus 6. Okay, I'm not very sure, but I believe that you have interpreted the question incorrectly, because for the second one, I cannot have this as just a non-red. I need this to be for example, white, then after that black color, because I need to make sure that these two are also different. So I cannot say it is non-red then non-red. What if both are white or both are black? then it would have stopped at 3. That is why I am specifically making sure that there are 3 different colored socks. 3 different colored socks. 3 different colored socks. Okay, this is when I'm going for a non-red, because it is just one sock. Then the next one is going to be red. So this one is a non-red. This is a non-red, this is a non-white, and this is a non-black. But here I cannot do this because I'm considering S is equal to 4. So I want to make sure that these are not just non-red, these are also different colors. So now we have our probability distribution, and I'm going to draw it here as small letter s. Goodness, my horizontal line is just very curvy. Then probability of s is equal to s. So we know there are only 3 possible cases. We have this, and this is going to be 1 over 3. This is going to be 74 over 165. And here this is equal to 12 over 55. Okay. Let me remove this. And let's calculate the expectation of S. The expectation of S, this is going to be summation of S multiplied by the probability that S is equal to S. What? Wait, hang on. For PH, right? I think you are misinterpreting the question a lot. You know why? Because you are not reading this statement here. You will draw until this. I think that's why you're asking this question. You will draw until the socks color matches, then he is going to stop. So it is not possible for him to draw all the way until S is equal to 12. Okay, that is why this is not good. We cannot go for 6 and non-6. That's why this is not possible also. It is impossible for when we have only 3 different colors for this person to draw 12 socks and not get similar colors. It is impossible. So this here, it is going to be 2 multiplied by 1 over 3 plus 3 multiplied by 74 over 165. And that is why just now we were trying to analyze whether it is possible to be 5, and we realize it is impossible already, because for this person to draw 5 socks, that means the first 4 socks must be of different colors, and we only have 3 different colors, so it is impossible for us to get 4 different colored socks. That's why 5 was impossible. And plus 4 multiplied by 12 over 55. This will get us the expectation of S. Expectation of S is equal to 476 over 165. And we are supposed to find the variance of S, and we will find the expectation of S square first, which is going to be summation of S square multiplied by the probability that S is equal to S. So this will be 2 square multiplied by 1 over 3 plus 3 square multiplied by 74 over 165, and then 4 square multiplied by 12 over 55. And this gives us what is this? This gives us 1462 over 165. And finally, to get the variance of S, it is going to be expectation of S square minus away the expectation of S square. So this will be 1462 over 165 minus away 476 over 165 square. And this is equal to 0.538. There's something that I find a little bit strange about this question, which is the marks allocation. Because so far, I've always seen this being given 3 marks. Because 1 mark is usually going to be given for the calculation of expectation of S, another mark is going to be given for the expectation of S square, and finally, a value that is for the variance of S will get you 1 mark. That is why, in fact, I think it is the first time I am seeing a question that is like this being given just 2 marks. I mean, if it is a very simple one, I can understand. I've seen that before, but this is a full-fledged expectation followed by variance question depending on the probability distribution table alone. So I'm not sure. I'm just a little bit surprised that it is not 3 marks. And it is okay. You don't have to leave it in fraction. You can go for decimal. But I mean, and if you want to use GC table, I think it is also possible. But it is simple enough, so I don't think I'll use GC table. I'll just do the multiplication directly. It is already pretty fast. Forgot to multiply the 2 in step 2, then you lose all the marks. Multiply by 2 in step 2. Did I forget to multiply the 2 in step 2, or were you talking about part 1 where I didn't multiply by the 2 factorial? Yeah, if I didn't multiply by the 2 factorial in part 1, I will lose a mark for expectation of S, definitely. Expectation of S square, I will not get the mark, but I think I may still get 1 mark for this. Oh, no, but this is a 2 marks question, so I'll probably lose all the marks. You're right. Next, part 3. Part 3, I want to find the probability that Drew took more than 2 pulls to obtain a pair of matching socks for 7 consecutive mornings. More than 2 pulls, that means it is this, right? 3 or 4. So the probability is going to be 1 minus 1 over 3, or of course you can take 74 over 165 plus 12 over 55. And this happened for 7 consecutive mornings. So it's going to be this multiplied by this 7 times. So it is this to the power of 7. My answer here is equal to 128 over 2187. Question 6. Next, let's take a look at question number 7. Question number 7, Peter and Kelvin, they are brothers. They went to a party together with 6 other friends. And there are 8 chairs for the 8 people. Given that at least one other person must be sitting between the 2 brothers, I want to find the number of different arrangements. It is a 2 marks question. I want to find the number of different arrangements for the 8 friends to be seated at the table. And I think the easiest way is definitely to do a complement. So I'll take for 8 people sitting around the table, it will be 8 minus 1 factorial. Then I'll minus away the case where the 2 brothers are sitting next to each other. So it is going to be this case. Then I have a 1, 2, 3, 4, 5, 6 other friends. So I have 1, 2, 3, 4, 5, 6, 7 objects. 7 minus 1 factorial. And for the 2 brothers, I'll multiply this by 2 factorial. This is going to give me 3600. This is part 1. I guess you are right. But maybe they are talking about something that is going to be happening, not what that has already happened. So they went, so I guess it is past tense. Let's say this is a 2019 birthday party. Anyway, part 2. Then the friends decided to play these musical chairs. There are 5 chairs. Oh, 5 chairs. Okay. And they are going to be placed in a row. Peter is not going to be getting a seat, but Kelvin is going to be sitting at the middle. So we have 1, 2, then Kelvin. Fixed in the middle, then this. So how many ways can we be arranging the people for all this when all the 5 chairs are going to be occupied? Kelvin is already fixed and Peter is not going to be in one of our selection. So what we will do is, out of the 6 friends, we will choose 4 of them to be occupying these 4 seats. Then they can be arranging themselves amongst these 4 seats. So multiply by 4 factorial. This is going to give us a 360. Okay, next part 3. Part 3 is complicated. Part 3, we are having this now, these 8 friends. They are going to be watching, they are going to be deciding which of the 4 movies to watch. They will be voting, and the movie that is going to be watched is going to be the one that is of highest votes. I want to find the total number of ways that 8 friends could have voted such that the movies are tied for the highest number of votes. The movies are tied for the highest number of votes. And we have 4 movies. Let us get the scenario of what that is happening. For example, we have movie 1, we have movie 2, movie 3, and movie 4. So if let's say movie 1 and movie 2 are going to be selected, that means they must be of the highest vote. And according to what the question says, the highest vote must be a tie. So for example, 4, 4, then 0, 0. This will be what the question is trying to ask us for, right? This will make sure that for the movie that is going to be, for the movies that are going to be having the highest votes, it is going to be tied. So 4, 4, 0, 0. So for this case here, I'm going to call this case 1. Case number 1. For this case here, 4 people will be choosing this. So out of 8 people, we will choose 4 of them to be choosing this. Then out of the rest of the 4, we will choose all the rest of the 4 to be choosing this. But we are not talking about them choosing just movie 1 or movie 2. They can be choosing any 2 of these movies. Any 2 of these movies can be voted for. So out of the 4 movies, we will choose 2 of them to be voted for, and then 4. And this is the number of ways for this to happen is 4, 2, 0. Let's look at another case, case 2. So if I have a movie 1, movie 2, movie 3, and movie 4. Let's say a tie is 3, 3. Then we can also have a 1, 1. There are 8 people, so 3, 3, 1, 1. So out of 8 people, we will choose 3 to be voting for movie 1. Then we will have 5 left. We will choose 3 to be voting for movie 2. And then 2 left. 2 choose 1 and 1 choose 1. And like what I was saying here, we are not talking about just movie 1 and movie 2 to be getting 3 votes each. It can be any of these 4 movies. So out of the 4 movies, we will choose 2 of them to be getting 3 votes each. And the rest of the 2, we will just choose both of them to be getting 1 vote each. And this is going to get me a 6, 7, 2, 0. Let me explain this again very quickly. So we want this to be happening for our case 2. So out of 8 people, we will choose 3 of them to be choosing movie 1. Then the next 5 will be choosing movie 2. Sorry, 3 of the next 5 will be choosing movie 2. Then 1 of the last 2 will be choosing movie 1, and the last person will be choosing movie 4. Sorry, movie 3, then after that movie 4. But we are not talking about just 3 being choosing movie 1 or movie 2. They can be choosing any of the 4 movies. So out of 4 movies, we will choose 2 of them to be voted 3 and 3. And then the last 2, they will be voted 1 and 1. We can try to exercise this idea again. For example, movie 1, movie 2, movie 3, movie 4. It can be 3, 3, then 2, 0, correct? Which means that out of 8 people, we will choose 3 to be voting for movie 1. Then 5 choose 3 to be voting for movie 2. And then 2 choose 2 to be voting for movie 3. And no one vote for movie 4. And we need, of the 4 movies, we need 2 of them to be getting 3 votes each. So out of 4, we will choose 3. And for the last two movies, one of them is going to be getting 2 votes. So out of 2, we will choose 1. And this gives me a 6720 also. So out of the 8 people, 3 of them will choose one movie. For the next 5, 3 of them will be choosing the next movie. And then for the last 2 people, they will be choosing the third movie. And of the 4 movies, we want 2 of them to be getting 3 votes each. So 4 choose 3. Sorry, not 4 choose 3, I realize this is 4 choose 2. So out of the 4 movies, we will choose 2 to be getting 3 votes each. And out of the next 2 movies, we will choose 1, 2 choose 1 to be getting 2 votes. Then this is going to give me 6720. And finally, there is still one more case that I can think of. If I was to talk about movie 1, movie 2, movie 3, and movie 4. The last possible scenario will be 2, 2, 2, 2. So out of 8, we will choose 2. 6, we will choose 2. 4, we will choose 2. And 2, we will choose 2. This is equal to 2520. So the total number of ways will be 420 plus 6720 plus 6720 and then a 2520. This is going to get us our final answer of 16380. Okay, this is question number 8. Next, let's take a look at this hypothesis testing question. So for this hypothesis testing question, we are supposed to be testing whether the mean is 200. And we're going to be testing an alternative where it is supposed to be more than 200. At least Wally is trying to test whether he's going to be getting more than 200. A sample is going to be done for 36 different income month, and then the data is summarized as this. We are supposed to do a 10% level of significance and stating symbols. And I think now that you guys have finished your prelim, you know how important this part is, right? Because I think some of you probably didn't write this during your prelim and then you lost 1 mark for this. So I'm going to say mu is the mean monthly income. Please take note, mu is not the income, but the mean monthly income. Then sigma is going to be the standard deviation. So for this hypothesis testing, we will be doing a H naught, which is mu. The mean monthly income is thought to be 200. And he is going to be testing whether mu is going to be bigger than 200, a right tail test. The sample size that we are looking at is a sample size of 36. And we can calculate the sample mean. The sample mean is going to be summation of x minus away 200 divided by n plus 200. I'm using the extended formula that I've listed on the theory outline for sample mean distribution. So this is 662.4 divided by n. N is 36, then plus 200. And x bar here is going to be equal to 218.4. And we will also be needing the population variance. And we don't really have the population variance, so we are going to do an estimation by using the unbiased estimate to the population variance. This will be 1 over n minus 1, summation of x minus 200 square minus away summation of x minus 200 square divided by n. So this can be calculated as 1 over 36 minus 1 multiplied by, this is 307,141.56 minus away 662.4 square divided by 36. And this is equal to 8427.24. Goodness, I didn't really see this, but I realized this is such a huge number. uh I mean, this number indeed makes me feel a little bit uncomfortable because the mean monthly income is fluctuating at plus minus of square root of this number. It's such a huge fluctuation in terms of the mean monthly income. Okay, we are going to write down our test statistics. And our test statistics is going to be x bar as one that follows a normal distribution with a mean of 200 and a variance of 8427.24 divided by n, 36. And the reason why we can write down this is because n is large. Since the question didn't tell me that the monthly income follows a normal distribution, so I'm writing down this as an approximation. Approximated by the central limit theorem, since n, which is equal to 36, I am going to perceive this as a number that is large. And okay, let me just write down the standardized version. So x bar minus away 200 divided by square root of 427.24, this divided by 36. This will follow a normal distribution of 0, 1. And I'm going to press this into my graphing calculator to get the p-value. The p-value from my GC, this is going to be equal to 0.11456. And we are testing at 10% level of significance. So since p-value is bigger than 0.10, so we see that there will be insufficient evidence that this, which is the mean monthly income, will be more than $200 at 10% level of significance. Yes, I will say you will try to use stats, but there are times when you can actually make use of data. Let me hang on. Let me think whether I can give you a scenario where you will make use of data. Okay, I think it is actually pretty safe to just go for stats all the time. If you are going to be using data, that will be when you press, for example, this data that is given, which is not in this form, but they give you a frequency table. Oops, my horizontal line. So if they were to give you a frequency table, let's say frequency and then x, so you will press this into your L1, you will press this into your L2. After you press this into your L1 and L2, right, then if you were to press for data, you actually see them automatically calculating for you the sample mean. And yeah, they will automatically calculate for you the sample mean. So I mean, if you want that, then you can use data. And of course, I can still calculate for my sample mean separately. Then I manually key in if I were to choose stats. So if it is confusing, I would suggest just go for stats all the way. And explain what it means by 10% level of significance. I guess this is pretty standard now. So 10% level of significance means that there's a probability of 0.1 in concluding that the mean monthly income has increased when in fact it has not increased. Okay, that is a pretty standard answer, but it comes with a very deep meaning, because this sentence alone basically summarizes the entire reason why we are doing hypothesis testing. So if you have been memorizing this, I would suggest that if you can actually spend some time, or if you can actually find some time, I'm so sorry, because I realized that with practical that is this week and next week, and at the same time you guys are trying to really finish up all the TYS. A lot of you are really short of time, but in case you are able to squeeze out some time, do go and check it out. What exactly is this statement representing, instead of just memorizing it to answer a question, very typical question that is like this. Because if you can uncover the reason that is behind this statement, you can probably understand hypothesis testing a little bit better also. Okay, let's look at question number 9. Question number 9, we are looking at bacterial filtration efficiency, BFE. And for brand A, for brand A reacting to this bacteria, the BFE is going to follow a normal distribution. I've written it down here already. It's going to follow a normal distribution with mu, with the mean as mu and the standard deviation as sigma, or the variance as sigma square. And the question says that the probability, the proportion is also seen as the probability. So the probability that the BFE is less than this is the same as the probability that when the BFE is more than this. So we have a probability that A, which represents this BFE, is less than 95.70. This is equal to the probability that A is bigger than 95.78. We have a very, very typical question which can be solved very fast if I can just view this whole scenario on the bell curve, because I know the mean, which is mu, is going to be in the middle. And since the area that is on the right hand side of this number is equal to the area that is on the right hand side of this number, this tells me that this 95.70 and this 95.78 are such that they are the same distance away from mu. This will help us to calculate mu, which is the midpoint of these two. So it is 95.70 plus 95.78, this divided by 2. This gives me mu as 95.78. So 95.74 to 2 decimal places. Okay, that is for part 1. And part 2, we are looking at brand A surgical mask reacting to another bacteria and the distribution change. The distribution change, let me remove this. So the distribution is changed. Let me just conveniently change this also. So now the distribution is changed to 91.09 and this is 0.08 square. And as for surgical mask brand B, it has a normal distribution of this. Oh no, you're right, Alvin, I didn't go and find the variance. Okay, I better go and find the variance of part 1. No wonder I was thinking, why was it like 3 marks? Because I've forgotten the variance. Okay, reset. So mu and sigma square. And of these two pieces of information, I think I'm going to make use of the probability that A is less than 95.70. Sorry, it is more than. So I am given that the probability of A is more than 95.78. The probability of this is equal to 0.0912. And since now I have already solved for mu, I found it to be to 2 decimal places, 95.74. I can now solve for sigma by doing a standardization to this first. So Z is going to be bigger than 95.78 minus away 95.74, this divided by sigma. And this is equal to 0.912. I will insert this into the inverse norm on my calculator, and my inverse norm will give me a value that represents this. So from my GC, this is minus 1.3334, which will then help me to find the value of sigma. Sigma here is going to be negative 0.03 to 2 decimal places, negative 0.03 for sigma. Okay, and now I've done part 1. Part 2, I'm going to once again conveniently make use of what I've defined here. So now we are looking at this to be 91.09 and a 0.08 square. And for brand B, it is also following a normal distribution. So for brand B, I have also conveniently written that down here. So for brand B, we are having this. We are supposed to be looking at the probability where the BFE of brand B differs from the sample mean of the BFE of n samples of brand A differs. So I know I'm going to take this minus this with a modulus differs. And we are for the BFE of brand B, it is already following this. But for the sample mean of n random samples of brand A, we still got to try to find work out another distribution, which is A bar. A bar is going to follow a normal distribution with 9.09 and a 0.08 square over n. This is for the sample mean of n random samples of brand A. And we are looking at also A bar minus B, because we are going to be looking at brand B differing from brand A. Brand B differing from the sample mean of brand A. So it's B minus A or A bar minus B. We're going to try to find the distribution of this. So first, let us try to work on the expectation of this, which is going to be the expectation of A bar minus away the expectation of B. So that will be 91.09 minus away 92.19. This is minus 1.1. We will find out what is the variance of A bar minus B. The variance of A bar, this is 0.08 square over n. Then minus will become plus variance of B. This is going to be 0.03 square. So I know now that A bar minus B, this is going to follow a normal distribution with a mean of minus 1.1 and a variance of 0.08 square over n plus 0.03 square. And according to the question, when A bar and B differs, when they differs by at most 1.15%. So this should be less than or equal to 1.15. The probability is at least 0.9405. So this is bigger or equal to 0.9405. And with this that is given, we are supposed to find the least possible value of n. And what is n? Since n is an integer value, I'm going to make use of my graphing calculator, specifically the table in my graphing calculator, to solve for the least possible value for n. So I'm going to be pressing this into my calculator, pressing the left hand side to my calculator as minus 1.15, then A bar minus B, then 1.15. This is supposed to be bigger or equal to 0.9405. Let me show you guys what I have done pressing this into the calculator. I press this. Okay, I press this into the calculator with the lower limit as negative 1.15, upper limit as 1.15. the mean is negative 1.1. As for the variance, as for the standard deviation, it's going to be the square root of this, where n is going to be replaced by x. So I press this into the calculator and I generate a table, and this is what I've gotten from my table. I press this into the y1 of my table. Maybe let me just show you y1 also. So this was what I did. I press this into y1. Then after I generate a table, and I search for when y1 is bigger or equal to 0.9405, which happens at 50. So from my GC, we know that we are analyzing n, which is for x, and for y1, we are analyzing the probability of modulus of a bar minus b to be less than or equal to 1.15. And from my table, I can see that when n is equal to 49, this is equal to 0.9403. And when n is equal to 50, this is 0.9406. And when it is 51, this is 0.9408. So for it to be bigger or equal to 0.9405, here is when it happens. Therefore, I know the least possible n is going to be equal to 50. Okay, that is for part 4. Then part 3. For part 3, for part 3, we are looking at now the mass of the boxes that contains brand A and brand B. And I should have it here. Yes, my definition is here. So X, I'm going to define it as the mass of the box of that contains brand A, and then Y be the mass of the box that contains brand B. So for X, according to the question, X here follows a normal distribution of 203 and sigma 1 square. And for Y follows a normal distribution of 203 and sigma 2 square. It is a little bit uncomfortable to be seeing this because we don't actually have values of them, and yet we are supposed to calculate the probability. We are supposed to calculate the probability of 3 times of mass of brand A to be exceeding the total mass of 3 different boxes of brand B. We will be calculating the probability. The question is expecting us to be giving a number. So it's a little bit weird because I'm not sure whether it is possible for us to get a number. But let's say we should just continue first. So this will be 3 times the expectation of X minus away 3 times the expectation of Y, which is actually just 3 of 203 minus away 3 of 203, which happen to be equal to 0. And if I were to find the variance of 3x minus away y1 plus y2 plus y3, this is going to be 3 square, the variance of x, plus 3 times the variance of y, and this is going to be 9 times of sigma 1 square plus 3 times of sigma 2 square. Again, a little bit uncomfortable. So 3x minus y1 plus y2 plus y3. This will follow a normal distribution of 0 and 9 sigma 1 square plus 3 sigma 2 square. And what the question wants us to calculate for is for 3x to exceed y1 plus y2 plus y3. And according to what we have just planned, we know we are going to be bringing this over to the left hand side. So it is when 3x minus away y1 plus y2 plus y3 to be bigger than 0. And what is this? This is going to be equal to 0.5. Without even using our calculator, and that is definitely because the mean happened to be equal to 0. So for the probability when this random variable is bigger than the mean, which is 0, the probability here is just half of 1, which is 0.5. So yes, when we were starting out with this, it felt a little bit uncomfortable to be looking at sigma 1 square and so on, but because of the way that the question has planned, so I guess we still will be able to calculate it numerically. So it is reduced to be equal to 0.5. Next, something that will happen only in this year, hopefully it is only going to be in this year, which is for hypothesis testing to appear as another question. Because I believe one of them probably should have been a correlation linear regression question. So now we are having another hypothesis testing question. We have an investment manager claiming that the mean dividend yield is 12%. The sample size that we are talking about is 40. And since just now when it was at 36, we have already considered it as large, we will definitely be considering this 40 as large also. And for the sample mean is 10.9. The sample standard deviation is 2.5. I want to state the reason whether there's a need to make any assumption. I've already written down here, and this is what I've directly copied from the ACJC's solution. There is no need to make any assumption. Why? Because n is already large, and since the sample size is large, then we can approximate the sample mean to a normal distribution via the central limit theorem. That's why no additional assumption needs to be made. Okay, so this is part 1. Yeah, I also think that hypothesis testing is pretty fun, especially if you understand enough of the idea that is behind hypothesis testing. It is a very important topic, which I do think that for some of you, you will be using it again in your university. Unless you study math, or else I don't think you will see P&C again, but you'll probably do all the probability distributions. You'll probably do all the hypothesis testing, and definitely also correlation linear regression in your secondary school. These three are more application based, and they're going to be very, very useful for research. So this is part 1. The definitions are not fun. Okay, I'm going to erase this, and I'm going to do part 2. And I'm not going to define the symbols, okay? So let's just take it as you guys have no problem defining all the symbols. So for H0, we're going to be doing a 5% level of significance to check whether the manager has overstated. So H0 is such that mu is going to be equal to 12. And H1 is such that mu overstated, so mu is going to be less than 12. And that we are looking at here is 40. And the sample mean, I'm going to go for X bar. The sample mean is given to me as 10.9. As for the population variance, which we don't have, so we are going to be estimating it. And the estimation of this is going to be dependent on the sample standard deviation. So it is n over n minus 1 multiplied by the sample variance. So this will be 40 divided by 40 minus 1 multiplied by the sample variance, which is 2.5 square. So sigma square here is going to be equal to 250 over 39. And I'm going to quote the sample mean, I'm going to quote the test statistics. The test statistics X bar, this will follow a normal distribution of 12, and here is going to be 250 over 39, this divided by 40. and we are also doing this based on an approximation. So this is approximated by the central limit theorem, since n, which is equal to 40, is considered as large. We cannot really tell whether overstated by itself is less than or more than. It has to be dependent on the context of the question. So now the manager claims that it is 12%. Manager claims that it's 12%. So if the manager has overstated, so we are looking at mu to be less than 12, because 12 is too much. Okay. And but there's a trick that I there's a trick that I do tell my tuition class students, which is if it is a one-tail test, because I'm pretty sure that what I'm looking at here, right, is not a two-tail test. So specifically, if I'm looking at a one-tail test and I have some doubts whether this is going to be less than or more than, I can actually make use of the sample mean. Because what you realize is that the sample mean will always support the alternative hypothesis. So let's say you have problem deciding whether overstated means less than or more than, but you know that it is a one-tail test. Then you take a look at the sample mean. If the sample mean is less than 12, then this has to be less than. You will always support the alternative hypothesis. So this is one rule that you can make use of to check, to make sure that you are quoting the alternative hypothesis, if it is a one-tail test, correctly, like it is applied all the time. And z is going to be x bar minus 12, this divided by 250 divided by 39 over 40. This will follow a normal distribution of 0, 1. So from here we can press our calculator to get a p-value. The p-value from my GC, this is equal to 0.00299999, and since this p-value is less than 5% level of significance, so since this is less than 0.5, so we found sufficient evidence So we have found sufficient evidence that the manager has overstated at 5% level of significance. Yep. And then it is known that the standard deviation of the dividend yield is 2.3. So what is this 2.3? This 2.3 will be the population standard deviation, which means that for this statement that is given to me here, this statement here tells me that now this is equal to 2.3 square. The sample size is changed to n, and it is found that the sample mean is 10.2. I want to give two assumptions such that the test can be carried out, such that the hypothesis testing can be carried out. Let me remove this first. Two assumptions, I have actually also written it down here already. So the two assumptions, let me bring it up. So these are the two assumptions. Number one, we will assume that the manager has randomly chosen the client's dividend yield as the sample. And number two, we will be assuming that the distribution for the dividend yield follows a normal distribution, so that we don't need to apply the central limit theorem, because we are talking about n that is small, so the central limit theorem cannot be applied anyway. Okay, so this is part 3. Let me remove it. Okay, so now we have done our assumption. Let's take a look at part 4. Part 4, hence find the least possible value of n. Find the least possible value of n such that the manager's claim is going to be rejected. The manager claims that the mean dividend yield is 10.2. Mu is equal to 10.2, and we are going to be rejecting the manager's claim. So we are talking about now not equal to 10.2. N is an unknown. We are supposed to be solving it. As for the sample mean, x bar is given to us as 10.2%. The population variance, like what we were saying, it is now given to us directly. So it is going to be 2.3 square. The test statistics that we will be working on is x bar that follows a normal distribution with a mean of 10.2 and a variance of 2.3 square divided by n. And because we have already assumed that x follows normal distribution, that is why we do not need to put out by central limit theorem, because this x bar here, which is a representation of x1 plus x2 plus x3 all the way until xn divided by n. And if all the x here follows normal distribution, this is just going to be a linear combination of n numbers of normal distribution, which will still result in a normal distribution. It is not an approximated value. It is an actual, it is the normal distribution. And according to the question, we are supposed to be rejecting the manager's claim at 5% level of significance. So to be rejecting the manager's claim, to be rejecting H naught at 5% level of significance. If I were to draw a bell curve that represents my test statistics, we know here is a 10.2, and the critical region is going to be on both sides, since we are talking about two-tailed test, which means that this area here is going to be 0.05 divided by 2, and this area here is 0.05 divided by 2. And since a rejection has happened, that means the evidence that we have collected should be within the critical region. So 10.2 is going to be here. Using the geometry of my graph, I know that the area that is on the left hand side of 10.2, this area should be less than this area. So the probability that x bar, this is x bar. So the probability that x bar is less than 10.2, this is an area that is less than 0.05 over 2, which I can also rewrite it as probability that x bar is less than 10.2 minus 0.025 is less than 0. And the reason why I'm doing this is because I'm going to press this into the y1 of my calculator. Since n is an integer value, my decision is to try to solve this by using table. So let me show you what I have pressed into my calculator. I press for, this is part 4. So I press this into the y1 of my calculator. The lower limit is going to be negative E99, upper limit is going to be 10.2, mu is going to be equal to, I wrote this wrongly, I realized. 10.2, I'm so sorry, this shouldn't be this, because we are still trying to check whether it is 12, so it should be 12. This is 10.2, this is 12. How can 10.2 be here, right? So this is 12. So let me repeat again. The lower limit is going to be negative E99. The upper limit is going to be 10.2. Mu is going to be equal to 12. And sigma is going to be square root of this, where n is going to be replaced by x. And I will minus away 0.025. So in my y1, I will have this. What you cannot see that is being truncated is minus of 0.025. Then I will generate a table. Let me show you my table. This is what I've gotten as my result. From the table, I'm looking for something that is negative. So from my table, I will have n, and I'll be looking at y1 to be representing probability of x bar to be less than 10.2, minus away 0.025, and n, when it is 6, it is a positive number, 0.0026. When it is 7, it is a negative number, negative 0.006. And when it is 8, this is negative 0.012. And I'm looking at negative numbers, and we are looking at the least possible value for n. So the least possible value for n is equal to 7. Okay. And this is the second last question, which means that I will be expecting that the last question is going to involve binomial distribution, right? Because so far we have not seen any binomial distribution yet. So most likely it's going to happen here, and it will be happening. It is going to be happening on the second half of this question. This question has quite a fair bit of explanation, so let's see how it is being set. It is estimated that 5% of the population is going to be infected with the disease, and a quick test is going to be done. The test for an infected person to be tested positive, it is 90% of the time, and for a non-infected person to be tested positive, it is 6% of the time. We are supposed to draw a probability tree that represents this scenario. So for part 1, I think this is a pretty easy probability tree to sketch. So we are talking about someone being infected or someone not infected, and to be tested positive, or to be tested negative. The same for here, to be tested positive, to be tested negative. Let's fill in the probabilities. For a person to be infected, 0.05. So here it must be 0.95. For someone to be infected, to be tested positive, it is going to be 90% of the time. So here will be 0.10. For someone who is not infected to be tested positive, it is going to be 6% of the time, so 0.06. And this will be 0.94. We are supposed to find the probability that the test is accurate. For the test to be accurate, that means somebody who is infected must be tested positive. So 0.05 multiplied by 0.90, or someone who is not infected must be tested negative. So 0.95 multiplied by 0.94. So for part 1, my answer here is 0.938. And for part 2, we want to find the probability that a person is infected given that he is tested positive. We are talking about conditional probability. Probability that a person is infected given that this person is tested positive. So it will be a person being tested infected and tested positive. divided by someone who is being tested positive. That will be someone who is being infected and being tested positive. Or someone who is not infected and being tested positive. And this is equal to 15 over 34. To increase the accuracy, a more comprehensive lab test is going to be done. Give one reason why a more costly or a more comprehensive but more costly lab test is going to be done. Give a reason why you will recommend the people who has been tested positive to be sent for this lab test. Give a reason why those who are tested positive should be sent for a lab test. Let me show you ACJC's solution, which is here. So someone who is being tested, give a reason why you recommend people who are being tested positive should be sent for the lab test. So from what we can see in our answers, from our answer in part 2, we see that for those people who are being tested positive, only like 44.1, 15 over 34 is 44.1. For those people who are tested positive, only 44.1% of them are going to be infected, which means that the test is actually not very accurate for those people who are being tested positive. And this is why they should be sent for another test, a more comprehensive and better test, because the chance of them being tested incorrectly is like too high. Okay. I assume I'm not sure, I'm very sure you're asking about the previous question. Most likely you have pressed the calculator wrongly, because the answer is supposed to be 7. And maybe you can check about maybe you can check the square root, maybe you can check the 2.3, whether you put 2.3 or 2.3 square. Small little numbers that are like this will usually cause you to make mistakes here and there. So I will suggest that if you are pretty sure of your process but you don't get the same answers, especially during this period as you are trying to prepare yourself for the exams, do not accept that you are definitely correct. Just check your calculator, check this and check that, to find where exactly is the problem. And so far from my experience, usually the problem just lies in somewhere along somewhere along the way. As you press the calculator, you just press it incorrectly. And let's state one drawback where only the people who is being tested positive is going to go for the lab test. What is one drawback? And ACJC has given one drawback. The drawback is that the people who are infected but they are tested negative will be omitted from the test. That is why this is one drawback. That means people who are infected but tested negative will not go for the test again. Then probably they are not going to be getting the kind of treatment that they need to. Okay, so that is for part 3. Yes, definitely. I think we are doing that, and you pay for it yourself. It is not going to be the government that pays. If you want to do it for the peace of mind, you can definitely pay for it yourself. Okay, let me erase this, and now we are moving on to the very last part, which is like what we have expected. There should be some binomial distribution somewhere, and it's going to be happening in the very last part. 5% of the population is going to be infected, and we are looking at a sample of 20 people, so it is already giving us the strong binomial distribution vibe. State one assumption such that this is going to follow a binomial distribution. a very obvious assumption that we can probably make, a very obvious assumption that we can probably make is this. This was also from ACJC, that someone being infected is independent of another person being infected. And we are supposed to do a calculation that there are fewer than 2 people being infected out of 20 people. So I am going to let x be the number of people infected out of 20 people that we are looking at. So x here will follow a binomial distribution out of 20, and the probability of someone being infected is now constant of 0.05. And we are supposed to calculate the probability where x is fewer than 2, so less than 2, which is calculated from my calculator as x to be less than or equal to 1. Since x is a discrete random variable, pressing this in the calculator, this gives us a 0.736. This is part 4, and then part 5. We actually need this number, so in case I erase this, let me write down the probability that x is less than 2 is equal to this number, and I'm going to write it down to 5 SF. So 73584. And part 5, I want to find the probability that for 20 people that are chosen, there were more than 2 people infected, and the first infected person was the 10th person to be chosen for the sample. It should be the 10th person chosen for the sample. That means there should be 9 people who are not infected, and the 10th person, this 10th person is going to be infected. Great. All the previous 9 people, they are all not infected, so the 10th person is going to be infected. So this will be the first person infected, and then subsequently the next 10. So for the next 10, there should be, because I want a total of more than 2 infected. So 1 is already infected, so here it must be more than 1. So together there can be more than 2. Correct? Okay, so this is the scenario. As for this, we are looking at 10 people because there are 20 people altogether, so there are 10, there will be another 10. So here I'm going to define y to be the number of people infected out of 10 people. So I'm going to be defining y to be following a binomial distribution of 10 and 0.05, which means that I'm talking about y here to be strictly bigger than 1. So that total, there will be more than 2 being infected. So the required probability will be the first 9 not being infected. Not being infected is 1 minus 0.05, and 9 of them, so multiply itself 9 times, so to the power of 9. Then this person is going to be infected, the 10th person is going to be infected. Then for the last 10, we want to make sure that at least 1 is going to be, not at least 1, more than 1 is going to be infected. So that total there will be more than 2 people being infected. So this is going to be 0.95 to the power of 9 multiplied by 0.05. And to calculate this, I will, as a binomial distribution, I will calculate this as 1 minus probability that y is less than or equal to 1. Pressing this into the calculator, I will get a 0.00271. This is part 5. And finally, part 6, the last part. Let me erase this. Oh, hang on. Maybe I'll just erase this. It's good for me to keep part 4 because I'll be using the result. So, part 6. A total of n random samples of 20 people. N samples of 20 people. given that there are at most 5 of the samples to have fewer than 2 infected people in each of the sample, and the probability is greater than 0.1, I want to find the largest possible value of n. So if I were to let, for example, W out of n number of samples, which has fewer than 2 infected people, there's fewer than 2 infected people in each sample. Hang on, I'm looking at a question about question number 10. I'll probably come back to this later. I'm not very sure what the question is. Hang on, but let me just continue with this first. So for this, W here will follow a binomial distribution with n number of samples, and the probability that in one sample there are less than 2 people being infected is in one sample of 20 people, less than 2 being infected. So the probability that we're talking about is this, which I'm going to go for 5SF 73584. And the question is saying that the probability when W is less than or equal to 5, this is bigger than 0.1. And we are supposed to find what is the largest possible value for n. And since n is an integer value, I'm going to press this into the calculator to generate a table again. So we'll be pressing this into the calculator, where the number of trials is replaced by x. Probability of success is 0.73584 less than or equal to 5 into binomial CDF, and I'll press this into y equal, and I will generate a table, and this is the table that I have gotten. So from my GC, I can build for myself this table where I'm looking for something that is bigger than greater than 0.1. So n, then probability that W is less than or equal to 5. When it is 8, it is bigger than 0.1, 0.357. When it is 9, this is 0.1932, still bigger than 0.1. Then when it is 10, this is equal to 0.0958. It is starting to get less than 0.1. So from here, we can find the largest possible n. And the largest possible n will go is equal to 9. Yay, we have finished the paper.